Now today we start the new topic, ambiguity in context-free grammar. Now we can explain what is ambiguity and how you can reduce in the context-free grammar. Now the ambiguity in context-free grammar. Context-free grammar. First we want to explain the ambiguity. What is ambiguous? Ambiguous. Now ambiguous is a grammar which can derive more than one derivation tree for the same same length of the grammar, or you can say same string of the grammar, same string of the language. Then if you can draw some language from the with the help of grammar, then we can trace the multiple derivation tree. Now we can say in the simple word, ambiguous grammar. A grammar, a grammar is ambiguous if it can derive more than one parse or derivation tree for the same string of language. Same string of language. This is a one-line definition of the ambiguous grammar. Now, how you can prove that this any string that can be defined by the language has a multiple derivation tree. Suppose you are taking an example. Suppose a grammar is defined grammar like this: s tends to s plus s tends to s into s tends to id, and id tends to 1, 2, 3, 4 up to 9, like this. Now suppose there is a language. The language is in the form of like this. Suppose a language has the string 3 plus 2 into 4. This is a string. Then actually the result of this string is equal to 11. 4 into 2, 8 plus 3, 11. This is the result. But if you want to discuss with the help of derivation tree, then how to construct the derivation tree for this. Now construction of derivation tree for this example, derivation tree derivation tree. The derivation tree will start with the grammar. Then you can just write the string s is equal to 3 plus 3 plus 2 into 4, 2 into 4. This is a string, and there is a grammar. Then we are starting from the root node s. This s is a root node. Then from root node, first we want plus, then 2. Then we can derive this with the help of your grammar rule. S plus s with the first rule. The grammar is, again we can write here grammar. Then the second we want to 3, and then we want to 4. Then from s you can derive s tends to id, and from id you can derive 3. There is a leaf node. plus, then again from S we can derive this production S into S, then this S you can derive again ID, and this ID you can derive to the leaf node, and this S you can derive ID, and this ID you can derive 4. Now if you can formulate this parse tree, then you can get the exact result. But again there is some other parse tree. S tends to S into S, like this, just into this S. Again there is a parse tree for S into S plus S, S plus S, and there is again ID, and there is again 3 leaf node, there is again ID, and there is leaf node, there is ID, and there is again leaf node 4. And in this tree, if you can calculate the process process of this tree, then you can get the results 3 plus 2 5, 3 plus 2 into 4, that is equal to 20, and here 3 plus 2 plus 4 into 4, that is equal to 11, and there is 20. Then there is a same string and there is same grammar. You can derive two parse tree for the same string of the language. Then this type of grammar is called the ambiguous grammar, because they cannot give the correct result. They can provide the ambiguity, that which is correct and which is not correct. Then this is the big problem of this. Here again we are taking another example of the ambiguous grammar. The grammar is second example of this ambiguous grammar is like this. Suppose the grammar G is in the form of S tends to S B S, or S tends to A, S tends to A. Then if you want to draw the string W of the language from this grammar, if you want to derive the string W like this is equal to A B A B A B A B A B A B A. See the string which you want to derive from this particular grammar. Then if you want to derive this string from the grammar, then again we are draw the derivation tree for this. Now the derivation tree for this grammar is like this. Suppose you are starting from S, then you can form like this S B S. Again S can derive a leaf node, then again we can form S B S. From this again we can derive A, we can derive again S B S, then we can again derive A, and we can derive again A. This is the first derivation tree for this grammar. Again if we want to make the again next tree, means second tree for the same string, then this may be like this: s tends to s tends to s b s, and this s again may be s b s, and again this s may be a, this s may be a, and this s again can be derived two part: s b s, again this may be s means a, again this is the leaf node a. Then for the same string we can derive two positive for this and this. This is called the ambiguous grammar. Then the question is how to reduce the ambiguous grammar to unambiguous. Now the question is how to convert ambiguous grammar to unambiguous grammar. Then we can convert the unambiguous grammar. Unambiguous grammar. Ambiguous grammar. Here the methods, we can just take the some example, or you can say you can take some assumption. You can say in the form of mathematical terms, that you can say mod of the example of this, that you are using the priority of the operator which are using in mathematics. Then here is some example how to convert the ambiguous grammar to unambiguous grammar. And we are again write the example. We are already taken the in the previous that grammar like this: s tends to s plus s tends to s into s tends to id, id tends to 1 2 3 4 up to 9, like this. Then there is some operator, the precedence operator, plus then a multiplication, then there is a symbol id, and then id will be 1 2 3 4 to 9. Then the precision operator, we can just explain the any algebraic fraction, that will be 2 plus 3 into 4. The expression algebraic fraction, this give the result is equal to 12 plus 2 14, 14 the result, correct result. But in the past tree, or you can the derivation tree, that can generate the different derivation tree for this, then they can give the different results. Then how you can reduce this ambiguity into the unambiguous grammar? We can just put some assumption here, according to precedence of operator plus and minus the same precedence here, same priority, multiplication division have the same priority. Then we are using the third variable, and this third variable may be taken assumption the grammar. Suppose we are using the plus and minus for one variable, multiplication division for another variable. Suppose we are taking the same example, and we are taking the assumption for grammar. Then s tends to new grammar s plus s oblique t, and there is an again t tends to t into t and f, and again f tends to id, and id tends to 1 2 3 4 up to 9. And there is unambiguous grammar. Unambiguous. There is S. Then there is a precedence. Precedence for plus and minus. Plus and minus. And there is a precedence for multiplication and division. Then there are two operators we are using here, extra operator means variable t and f. Then if we want to derive the same string 2 plus 3 into 4 with the help of this unambiguous grammar, then we can form the exact result with the help of this reduced grammar. Suppose the positive for the any with the help of this new grammar, we can put it here. Suppose the string w is like this. W is like this: 2 plus 3 into 4, 2 plus 3 into 4, that is a string w, and the grammar is given. Grammar is s tends to s plus s oblique t, t tends to t into t oblique f, f tends to id, and id tends to 1, 2, 3, 4 up to 9. This is a given grammar. There are two variables t and f. We are taking third variable and fourth variable for the derivation of ambiguity, reduce the ambiguity. Then for derivation tree for this w, we are starting from s. The s is the starting symbol of the grammar. Then we form the two symbols. That is a 2. That is a s plus s. Then again we can form s. There is again an t. Then there is again a f. Then there is again an id, and there is again a symbol 2. The leaf node. The plus sign again we require for this. Then again we can convert this to. We cannot directly get the into sign with the help of s. Then you can form t. Again t can form t into t. Then t can form t into t. This t again can form. We have required 3. We require 3. Then we can go to f. We can go to f, and we can f can derive id, and id can derive 3. And similarly, t can derive f. F can derive id, and id can derive 4. Then this can result the result 2 plus 3 into 4, 3 into 4 12. That can derive the exact result, that is a 2 plus 3 plus 4, that is 14. That is the correct results, and we can you can derive only one past tree or one derivation tree from this grammar, and that is the unambiguous grammar, and that can give the unique solution. That solution is correct for the algebraic law. Then this is the methods how to convert grammar into unambiguous grammar